Now we will start with the nodal and the mesh analysis. So these are the two very most important circuit analysis techniques. Okay, so we will start with the nodal analysis. So the very first step in nodal analysis is to identify the all of the nodes. So we have already discussed what is meant by a node. It is the meeting point of two or more elements. Okay. For example, if you have a resistor here and another resistor here, this is a node. You can connect, there may be more elements. Okay. How many ever elements they are connected? It is called a node. Okay. So first you have to identify all the nodes and select one of them as a reference node. As reference, or it is also sometimes called as the datum node. Now let us consider the number of nodes. We will take this to be a variable n. Okay. Now what is the second step? You have to assign the voltages to each of this node. Okay, except the reference node. For the reference node, the voltage will be 0. So assign voltages to each of the non-reference nodes. Okay, and you can also write and assign 0 voltage to reference node. And the next step is you have to apply KCL at each of the non-reference nodes. Each of the non-reference nodes, and the equations, they should be in terms of the equation should be in terms of the node voltages that we have assigned in step 2. Okay, so this point is important. And what is the final step? You have to solve all of the equations. Solve KCL equations. What is KCL? Kirchhoff's current law, right? So solve KCL equations to find the node voltages. Once you get the node voltages, then the currents also you can find out. So here we will take one example. Okay, so find the node voltages V1 and V2 from the following diagram. So here we have a resistor, here there is another resistor, and here you have a current source. And here also you have a current source. Okay, so this is the, and here ground is also given. So usually the ground node is taken as the reference node. So this current source gives 3 amperes and this current source gives 12 amperes. This is 6 ohms, 2 ohms and 7 ohms. Okay, and this voltage here is V1, this voltage is V2. Okay, so now if you see the nodal analysis, the step 1 is to identify all the nodes, but here in the question itself they've given all the nodes. There are 3 nodes. This is one node, second node, and this is the reference node. Okay, and step 2 is to assign voltages. That is also done. In the first node we have assigned, the question itself has given V1 voltage, and in the second node the voltage is V2 voltage. Okay, so now we have to start with the third step. Okay, so what is the third step? To write the KCL equations. Okay, so applying KCL at node 1. So the currents entering should be equal to the currents leaving the node. Okay, so just for the sake of writing the KCL equation, I will just draw this once again. So here 3 amperes from the current source is entering. This is 6 ohms. This voltage is V1. This voltage is V2. And this voltage is the reference node. Okay, so we will take the currents to be in this direction in the resistors. Okay, so now 3 is equal to the current through 6 ohms plus the current through 2 ohms. So what we do is this current we express in terms of the voltage. Okay, so now the voltage we should write V1 minus V2 or V2 minus V1. Okay, so whenever a resistor is given, if the current is flowing in this direction, then the polarity is taken to be this is positive and this is negative. Okay, so this is the polarity that will be formed across the resistor. For a voltage source, the polarity is given, right? But for a resistance, the polarity will be formed according to the direction of the current. Okay, so now this is 6 ohms. So whichever terminal through which the current is entering, that will be the positive terminal. So whenever we write the voltage across this, we write as this voltage. If this is V1 and this is V2, then we write as V1 minus V2. Okay, so here 3 is equal to the current through 6 ohms is V1 minus V2 divided by 6. What about 2 ohms? Here we have to write V1 minus 0 divided by 2. This is the first equation. Okay. Now the next equation, KCL at node 2. Here also we will once again redraw the node. So this is the node 2 and here the current source. So here 12 amperes is leaving. Okay. Now what is this voltage? This is V2. This voltage is 0 and this voltage is V1. Okay. Now when we were applying KCL at node 1, then we took the currents to be leaving the node 1. When we are applying KCL at node 2, then once again we take the currents to be leaving the node, that particular node. So that means we will take the current directions like this. This is the current direction and this is the current direction. Okay. So don't get confused. Only for the sake of writing the equation, we are taking the direction. Okay. The actual direction we will get to know after we complete the nodal analysis. Okay. So here what is the equation? We will see. The current, that is all the currents are leaving. So all of them will be on one side only. So you can write 12 plus, this is 7 ohms and this is 6 ohms, right? So what will be the current through 6 ohms? The voltage across it, which is V2 minus V1, from whichever direction the current is flowing, that one we will take first, divided by 6, plus the current through 7 ohms is V2 minus 0 divided by 7. This is equal to 0. So this is the second equation. So now we have two equations in two variables. So what are the two equations? Equation 1, if you simplify, you're going to get 4V1 minus V2 is equal to 18. This is the first equation. And the second equation, if you simplify, this is the second equation, right? So you just write it in a different form. So you're going to get 7V1 minus 13V2. This is equal to 5, not 4. Now if you solve both of these equations, then you're going to get V1 is equal to minus 6 volt and V2 you're going to get minus 42 volt. Okay. So now here I want to tell you one more method of solving. For smaller number of equations, it will not be that useful. But if there are more number of equations, then it will become useful. Okay. So that is the Cramer's rule of solving the linear equations. So we will see what that rule is. So here what you do is you write in the matrix form. So how will you write in the matrix form? Here you have V1 and V2. The other hand side you will write 18, 5 not 4, and here you're going to write the coefficients. So 7 and minus 13, right? Now from here you will get V1 is equal to delta 1 by delta. We will see what is delta 1 and delta. And V2 is equal to delta 2 by delta. Okay. So what is delta? Delta is nothing but the determinant of the coefficient matrix. So delta is determinant of 4 minus 1 minus 13. Okay. So you can write determinant of coefficient matrix. Okay. Now what is delta 1? In this coefficient matrix, you will replace the first column with the constant matrix. Okay. So that means what is delta 1? This is going to be, the second column will remain as it is, minus 1 and minus 13. The The first column you will write as 18 and 504. Okay. So this is delta 1. What about delta 2? Here the second column you have to replace. Okay. So the first column will remain as it is, 4 and 7. The second column you will have 18 and 504. Okay. So once you find the determinants, then you just have to substitute V1 is equal to delta 1 by delta and V2 is delta 2 by delta. You're going to get the same answer. So now we saw one basic problem on how to do the nodal analysis. A few points if you can remember, then your nodal analysis is complete. Okay. So what is this? If you have a voltage source in between a reference and a non-reference node, then how do you write the equation? See, this is the voltage source Vs, let us say. Now here there's one node and this is the reference node. Okay, so this voltage, let us say it is V1. Okay, then what will be V1? V1 is simply equal to the source voltage. Okay, you don't have to write any equations or anything, it is direct. So V1 is equal to Vs. You can just directly find out the node voltage like this. Okay. Now another case is voltage source, it is present between two non-reference nodes. Between two non-reference nodes. Okay. In this case, what will you do? So let us say there is a node here and there is a voltage source here. There is another node here. So this is V1 and this is V2. And this is Vs, let us say. Then what will be the equation here? V1 minus V2 is equal to Vs. So why V1 minus V2 and not V2 minus V1? Because whichever is positive polarity, that we will write as positive. V2 is on negative polarity, so we write minus V2. Okay. So now we only know the difference. The difference between these two is the source voltage. But how will you find V1 and V2? Right? You have only one equation and two variables. Okay. So this is where the concept of super node comes into picture. Okay. So we will do one problem relating to super node and then this will become more clear to you. So this is how to solve the super node problems. Okay. So the question here is, you have a voltage source here, a resistance, and here you have another resistance, here you have a voltage source. Okay, so this is the circuit and this is 6 volts, 14 volt, 4 ohm, 3 ohm, 2 ohm. Okay, now this is 6 ohms. So now the question is, find V and I. So V is given across the 3 ohm resistance and I is given across the 2 ohm resistance. Okay. So now you can see here that these are two nodes and in between these two, this is the reference node, right? So usually we take this as the reference node. So between two non-reference nodes, there is a voltage source. So we are going to have the super node here. Okay, so we will see how to solve this problem. So we will redraw this diagram. What is the first step? You have to identify the nodes. Okay, so this we will take as the reference node. Okay, and what are the other nodes? This is one node and this is one node. Okay, so you can see here that there is another node here between this resistance and this voltage source. But this is not necessary for us. If there are 3 or more elements, then only we usually consider as a load. If only 2 elements are connected with each other, then we can simply write the equation. So we will see how you can in fact take the voltage here, but this voltage is simply going to be 14 volt. Okay, so we simply don't take it. Okay, so what is the voltage here? We will take as V1 and this is V2. Now the first equation here is the difference between V1 and V2. What is V1 minus V2? This is equal to the source voltage, 6 volt. So this is the first equation that we have. Now the second equation we have to consider this entire 2 of the nodes as super node. Okay, so if you remember in KCL, we can apply the Kirchhoff's current law for an entire region as well. Okay, so whatever current is entering this region, the same current should be leaving. Okay, so now what are the currents that we need here? This is going to be, so whenever we apply KCL for nodal analysis, we take the currents to be leaving away from the node. Okay, so this is the direction of current we will take, this is the direction of current, this is the direction, and this is the direction through 6 ohms. Okay, now it is the same old thing. What is the equation? How do you write the equation? For this current, the voltage is, here is V1 and the voltage here is 14 volt. Okay, so this voltage you can write, this current you can write as, for this 4 ohm resistance, this voltage is V1 and this voltage is 14 and current is flowing like this. Then what will be the value of this current? It is going to be V1 minus 14 divided by 4. Similarly, for this 3 ohm resistance, what will be the value of current? V1 minus 0 by 3. For 2 ohms, what will be the, here you can see V2 is the voltage and here it is 0. So we write V2 minus 0 divided by 2. And for 6 ohms, similarly, V2 minus 0 divided by 6. Okay, so this is equal to 0. This is the second equation. So now also we have 2 equations in 2 variables. Okay, so now if you solve these 2 equations, I will write the final answer. You can verify it later. So V1 you are going to get minus 0.4 volt. You can in fact pause, you can solve the problem and then see the solution. Okay, so V2 is equal to 84 by 15 volt. But what is the actual thing that we need? We need the voltage V and I, right? So what is the voltage V? V is across the 3 ohms and the current through 2 ohms is the required current. Okay, so now what is V? Here V is nothing but V1 minus 0, which is V1. So this is minus 0.4 volt. And what about I? This is equal to V2 minus 0 divided by 2. Okay, so you're going to get 2.8 amperes. So I hope this is clear to you. Whatever questions you are going to get from nodal analysis, it is going to be in the same, these 2 models only. You will either get super node or normal node analysis. Okay, you might get more than 2 equations. You might get 3 variables, but more than that you're not going to get. Okay, so this is as simple as that.